Now let's try a free response question. Consider the function f of x is equal to x to the fifth divided by 4 minus cosine of x plus 2. And answer the following questions. Approximate the relative extrema of f. Find the linear approximation of f at x equals pi. And then use your linear approximation to approximate the value of f of 3. Is your approximation an overestimate or underestimate of the actual value of f of 3? And justify your answer. Let's get started. Let's start with part A, approximate the relative extrema of f. Well, since we're allowed to use a calculator for this problem, let's actually graph our function and use some of the calculation functions that it has. So go to y equals, and then type in your function, x to the fifth divided by 4 minus the cosine of x plus 2. And then when we graph our function, it looks something like this. And we can see that we have some sort of relative maxima here, and then it looks like a relative minima here. So let's try to approximate those with our calculation options. So we're going to do second trace, and we're going to do the maximum first. So that's option 4. And I'm going to go to the left of it, right here. Then I'm going to go to the right of it. And then I'm going to guess somewhere in the middle. And it gives it to me as negative 0.887. So that's one value. Negative 0.887 is one relative extrema. And that's when x is equal to that value. Now let's try to find what looks like a relative minima. So if I go to second trace for calc and then choose minimum, option 3, we are to the left of it. Now let's go over to the right a little bit. And then we'll guess in between, right about here. And it ends up being at our y-intercept. So this says 1.46 times 10 to the negative 6th. That's really close to 0. And the y-coordinate is 1. So that would be at x equals 0. And x equals negative 0.887. Now let's look at part B. Find the linear approximation of f at x equals pi. Well, we know that the formula for linear approximation is that y is equal to f of c plus f prime of c times the quantity x minus c. And remember, this comes from point slope. So it's your y1, or the function evaluated at that c value, plus the slope is the derivative of our original function evaluated at c times x minus c. So we know that we're evaluating this one at pi. So let's substitute pi in for all of our c values that we have here. Y is equal to f of pi plus f prime of pi times the quantity x minus pi. So the next step in this process is going to be to determine what the derivative of this function is going to be. Because in our linear approximation formula, there's that f prime and then evaluated at pi. So we have to first determine what f prime of x is going to be. So we know that f of x is equal to x to the fifth over 4 minus cosine of x plus 2. So its derivative will be, well, we can use the power rule here. The 4 in the denominator is going to remain the same, but we're going to have a 5x to the fourth in the numerator. And then we have minus, the derivative of cosine is negative sine of x. And then plus 2, well, the derivative of any constant is 0. So this minus a negative will become plus a positive. So we have 5 over 4, and then x to the fourth plus sine of x as our derivative. So now that we have our function and its derivative, we can then substitute the values of pi into our equation and derivative accordingly and evaluate. And when we do that, we'll get pi raised to the 5th power over 4 for f of pi minus cosine of pi plus 2. That's what the beginning part of this is. And then plus, well, f prime is this, and we're going to substitute pi in for x. So 5 pi to the 4th divided by 4 plus sine of pi, and then we have times the quantity x minus pi. The next step is going to be to simplify this equation by evaluating especially the trig that we can. For example, the cosine of pi we can evaluate. Cosine of pi is -1, so we're going to have minus -1 or plus 1, and then the sine of pi is 0, so this goes away. So that leaves us with pi to the 5th over 4 plus 1 plus 2 plus 5 pi to the 4th divided by 4 times the quantity x minus pi. And then from here, if we distribute the 5 pi to the 4th divided by 4 into both terms in the parentheses here, and we combine the +1 and +2 together to get +3, we will get this equation. Y is equal to pi to the 5th divided by 4 plus 3 plus 5 pi to the 4th divided by 4 times x minus 5 pi to the 5th divided by 4. Notice we have like terms here now. We have a 1 in front of this pi to the 5th divided by 4 minus 5 pi to the 5th divided by 4. And when we combine these together, that's going to be 4 pi to the 5th, or sorry, -4 pi to the 5th over 4. Well, these 4's are going to cancel out, so we just have minus pi to the 5th. So we have 5 pi to the 4th divided by 4 times x minus pi to the 5th plus 3. And that is the final answer to this question. Find the linear approximation of f at x equals pi. Now let's look at part C. Use your linear approximation to approximate the value of f of 3. Is your approximation an overestimate or an underestimate of the actual value of f of 3? Justify your answer. Well, we know that our linear approximation is y is equal to 5 over 4 pi to the 4th power times x, and then minus pi to the 5th plus 3. So let's substitute 3 in for our x value and evaluate. So here's what it would look like when we substitute the value of 3 in for x. And now let's switch over to a calculator and evaluate this. So we have 5 times pi, which is right here, raised to the 4th power. We're dividing that by 4. And then we're multiplying that value by 3. And then we're subtracting pi raised to the 5th power. And then we're adding 3 to that. And when we do that, we end up getting about 62 and 26/100. So that's the approximation for our function evaluated at 3. Now that we have our linear approximation for the value of f of 3, we have to determine if this approximation is an overestimate or an underestimate of the actual value of f of 3. And we can do that by analyzing where the linear function lies in relation to our regular function. So let's switch back over to our graphing calculator and go to y equals. Our original function is there, but now we have to put in our linear function. So we have 5, and then we have pi being raised to the 4th power divided by 4. And then we have an x after that, and then minus pi raised to the 5th power plus 3. And then if we graph, here's our regular function, and here is the linear approximation. Let's actually adjust our window slightly to make the intersection point of these two functions more visible. So let's go to Window. We can keep the x values in place, but since our function value approximation is at about 62, let's use a y minimum of, say, -5 and a y max of, say, 80. And let's make that y scale be 5. Now let's see what our graph looks like. So here we can clearly see it's below our regular function, so that makes it an underestimate. So we examined it, and we can clearly see that the tangent line in our graph is below the curve of f of x, therefore it's an underestimate.